All right, so this is part two. We're going to go ahead and try to put these trinomials into vertex form. So if you remember from part one, vertex form is y equals a times x minus h squared plus x, or plus k, where h and k are your vertex. Okay, so we're going to take each one of these and we're going to try to do that. So for 5, okay, for 5, we're going to go ahead and put in our plus and minus box. We do not have an a here. A is just 1, so we're not going to worry about what to do with a yet. I'll show you that on the next example. So we're going to put a plus box after 4x and a minus box after 1. So we need to, just like with completing the square, we're trying to get this first chunk to be a perfect square trinomial, and then the rest of it to just simplify like it did before, except now it's on the same side. Okay, so we have, let me erase that. So we're going to find b divided by 2, which is 2, and we're going to square it, and then that number is going to go into our boxes like before. Okay. So now when we rewrite our next step, we can write the perfect square trinomial, which is x plus 2 whole thing squared, and this will be a minus 3. So this one was a lot nicer because everything divided nicely. We have a equals 1, which we have a 1 here. That's what a should equal is 1. And our vertex now is going to be -2, -3. Our axis of symmetry goes through -2, and we should have a minimum at that same point of -2, -3, because a is a positive number. Okay, so that one's kind of nice, a nice way to kind of intro into this. So I want to jump down to number 7. I want to jump down to number 7 real quick. This is when a is not equal to 1. Okay, so these are the things we're going to do when a is not equal to 1. Okay, and we're going to try to contain it all to one side. So we're going to have y equals, I still need to divide out my a, but I'm going to keep it all on the right side. So all that means, GCF or not, okay, GCF or not, I'm going to divide out this 2. I'm going to pull it out like a GCF and not divide everything. Okay, so I'm taking it out using division like we have, but I'm going to treat it like a GCF whether it is a GCF or not. So what I mean is I'm going to take the a, which is 2, make my x squared. This is now a 5x. Okay, I'm going to go ahead and put my plus box in there. Now this is a plus 2. And then my minus box. So I took out the 2. So if I distributed, which we're not going to do, if I distributed this back into the numbers I do have, I should get the 2x squared minus 10x plus 4. We're not going to do that because I know that's correct. So now we have parentheses because the 2 is out front. Our a is 2. So the 2 is going to represent the a in the vertex form. So now we're going to take my -5 and we're going to divide it by 2 because that's b. And then we're going to square it because remember it should always be a positive number. So now we should have 25 over 4 and it should be positive. So it's positive there. And then this one will be negative. When we have office hours, we can walk through why that is. I'm sure some of you are thinking about it, but we'll say that for office hours for time's sake here. All right, so we should have y equals, we're going to write our 2 with our bracket, because we're going to have a couple sets of parentheses in here. Just like with completing the square, I'm going to put my x minus or plus or whatever my b divided by 2 was, and then I'm going to have some number out here from the highlighted portion. So I should have a minus 17 over 4, and then I'll have my end bracket. So we're not going to leave it like this because this is not simplified. So we need to take, the last thing we're going to do is we're going to take this 2, and that I'm highlighting, and we're going to redistribute it inside. So we're going to distribute it here in front of the first group, and then we're going to distribute it to the number that's left outside at the end. Okay, and that's where the 2 is going to go for now. So now the 2 sits outside the x minus 5 over 2 squared. And then 2 times negative 17 over 4 actually simplifies to 17 over 2. And now that's in vertex form. That's what we want. Because now I can tell you by looking at it that my vertex is 5 over 2, comma, negative 17 over 2. I can tell you that it's a min because A is a positive number. Okay. And I can tell you my axis of symmetry is that x equals 5 over 2. And remember, it's the opposite of what h is in here. So here's h, here's k, okay, h, k, and if you look at the original problem, I'll highlight it in different color. Our original problem, this A right here should match the A that's in our trinomial. So if you're not sure if you did that part right, those should match as well. Okay, and that's vertex form. That's what we've been trying to do, what we've been trying to find. So let's do one more example. Okay, let's do one more example. We're going to do, all right, so we're going to do example 10. Okay, we're going to graph it as well and find all that information, the AOS, your vertex, and your max or min. Okay, so same kind of thing. We're going to take out the negative 6. So x squared plus 2x. We're going to put a plus box in here. I should have a minus or a plus 13 over 6. And then I'm going to have a minus box and then parentheses. I'll take my b. So b divided by 2 gives me 1. 1 squared. That's what's going to go in here. So there's 1. There's 1. And then I'm going to bring everything down, put my brackets in, write my perfect square trinomial with the b divided by 2. And then I can do some math right here. So this should be plus 7 over 6. And then the last thing I need to remember to do is that negative 6 needs to come back inside to both spots, the one in front of the group and one at the end with that number. You're not distributing inside these parentheses, but you are putting the negative 6 out front, and then this should just be a negative 7. So now we are in vertex form. Our vertex is a negative 1, negative 7. So if you look where h and k are, h is a plus 1, which is the opposite of what we want. It's a negative, so it's a negative 1, negative 7. I know this has a max because a is a negative number. It's a negative 6, and that's what we started with. And then I also know that my AOS goes through negative 1. So if I wanted to, I could plug in that information to my graph. I can find my vertex, so go down 1, 2, 3, 4, 5, 6, 7. And I can make a small table from there. Okay, so this is where we're bringing back that graphing. So -2, -3, 0, and 1. We know -1, it goes with -7. 0 should be -13 because that's our y-intercept. Okay, and you can use either the trinomial or the vertex form that we found to find all of the pieces of information for your table. Okay, so -2, so that becomes -1 squared. So that's -13. So if I plug in -3, 2 squared, that's 4. That's a big number. 24, so -31. Okay, -31. All right, so we've got some big numbers here. We're going to just graph the one we can, which is just the vertex, is the way our graph is. But your graph should look something like that. And that's vertex form. All right. I hope that helps. Do the practice that's assigned. Have a good day.